Hello everyone, I'm Haricharan and I'm a candidate master in Codeforces. So let's have a look at the video editorial for Codeforces round 879. So during the contest I was able to solve problems A, B and C, and I was able to solve D after the contest. Okay, now you can pause the video and read the question for A. Okay, hopefully you have read the question. So the answer for this might be just simple brute force. So we know that n is like 100, right? So if we know that n is 100, you might simply be able to brute force over all the solutions. So we can, so we'll brute force over all the possible values for a number of minus ones you have. Okay, so that will be our basic solution. Brute force over over number of minus ones. Okay, why is this valid? So because the number of minus ones has to be less than n. So we can just use that because n is just 100, so it will definitely pass without any issues. Okay, so we can just simply brute force over all values of minus 1. So the number of minus ones you might have can be 2, can be 4, can be 0 also, can be 6, all the way up to n. So it can be basically any even number up to n. So we just iterate on all of these possible values. Now if in the initial array we had, let's say, m minus 1s. So in the initial array we had m minus 1s, and now we have, let's say, I minus 1s in the desired array. We can do it in m minus I operations, right? So that will be our basic idea. So you should be able to do it in m minus I operations. But of course there is one more condition also. So when you are iterating in this for loop using I, you have to ensure that I is smaller than n minus I, or smaller than or equal to. Actually, why is this? Because we know that I is how many minus ones you have. So number of minus ones, and that has to be equal to this, the number of ones, number of plus ones, right? So because only then the sum of the entire array will be positive, and that's the fact that we are using here. So let's have a look at my code also. So you can see, by the way, this REP is my macro for a for loop. So I hope that's clear. So I'm just counting how many ones we have and how many minus ones we have. So I hope that's clear. Now I'm initially keeping answer to be n. Why am I initializing answer to be n? Because we can always do it in n operations. So in n operations, we can just make every element equal to plus 1, and that will be enough. So we can always do it in n operations. Now let's iterate over the number of minus ones. Number of minus ones can be 0, can be 2, can be 4, etc. So we just iterating over all possible values here. This condition ensures that the desired sum of the array is positive, positive or 0. So this line ensures that, and then we are keeping answer equals minimum of absolute value of m minus I. So we are just doing that here, and we are just outputting answer. So I hope that's clear for problem A. So let's move on to problem B. Alright, so I'll open the question. So you can pause the video and have a look at the question. Now, what is the basic idea of the solution here, right? Okay, so there are a couple of possibilities here. Okay, so we'll move on to problem B. So problem B, yeah. Okay, so what will be the basic idea in this case, right? So let's think about this. We have two numbers. We have to input them as strings, obviously, because they are very big. So we have to input them as strings. We have two numbers, and let's call them L and R. Okay. Now, what are we doing? So we have to ensure, like, what is the maximum possible difference, right? So let's say if L was like 999 and R was like 1000, let's say, right? So then what will be the maximum possible difference? Well, you can just take one of the numbers to be 999, the other number to be 1000. And if you find the difference between their digits, you have to put a 0 here to ensure that, and the difference in this case will be 28. Like that is the basic idea here. Now, so let's move on. So now there are a couple of possibilities, right? They both could have the same size, or they could have the different size. So both L and R have same size. That means no 0 padding needed. So for instance, there's something like 579 and let's say 487 or something like that. So what you notice here is that some prefix of them might be equal. So you might have an initial prefix of them which is equal. Let's say you have something like 577 and 570. Sorry, I mean bad example, I guess. I'll take 571 and 579. So here we notice that the prefix of 57, that is actually equal. Okay. Now, if some prefix is equal, notice that we can't do anything at all. So we'll have a look at the first index which is actually not equal. So we'll have a look at this, the first index which is not equal, because if the prefix is equal, whatever number we choose, the prefix also has to be the same and we can't avoid it. So so that's why we are doing that thing. So now let's have a look at like what will be a final answer, right? So we can divide all these numbers into some prefix, some kind of middle number, like it's the, I'll call it the first not equal number, and some suffix. Okay. So so like we'll be able to find this first not equal number and then basically everything else, if that makes more sense. Okay. Now if the prefix is equal, we can't do anything. So this won't contribute anything to the answer at all. So we don't have to bother about this. Now let's have a look at the first non-equal number. So if I have, so let's say the numbers were 5719 and let's say 5730, right? For this prefix, I can't add to my total sum at all. So the differences will be 0 in this case, so not very useful, right? So instead, what will be the best thing to do? So let's think about this. So I'll try to maintain this one. I mean, I'll take an even better example, something like 5715 and 3735, let's say, right? Now, let's think about the first non-equal digit. So that's this 1 here and this 3 here. Now, in the ideal case, what I'll try to do is I'll try to generate something like 1, 99999, etc. And I will try to generate something like 70000, etc. Like how many zeros you have? 1 less 0, I guess. But yeah. So we'll try to generate something like this, and we know that this will lie in the range for sure, right? So this will definitely lie in the range. So even if I add a bunch of more digits, like let's say 57 here and let's say 43 here, it doesn't really matter. Like if you have the desired number of, so like if I have these two as my numbers, let's say something like 57, 3 and 000. So this will definitely lie in the range, right? So you can see that it clearly lies in the range. For each of these digits, your answer will be added by 9, and for this digit, your answer will be added by essentially the difference between the non-equal digits in that number. So if you look at whatever answer will be in first non-equal digit plus 9 times number of digits after that. So I hope that makes sense. So if I quickly look at my code also, I'll zoom it a bit. Yeah, so this is for the case in which they have the same size. So if Li is not equal to Ri, I'm setting that index to be equal to I and I'm breaking there. So this check is fairly easy. This check is to ensure that both of the numbers aren't equal, because if the index happens to be L dot size plus 1, it means L equals R, and if L equals R, your answer will be 0 because you can only choose one number. So this just ensures that the number is just 0. So then for every index after that, I'm just adding 9 to answer. I mean, technically I don't need a for loop for this, I can just multiply it, but it's fine, I guess. Yeah, so I'm just outputting answer here. Now let's have a case. So this was the first case, right? First case was have the same size. So now let's have a look at another case in which L and R have different size. When I say different size, of course, R has to be a bigger size because L is a smaller number. So L will be something like 000 and something else after that. And R will start at 1 itself, let's say 1, 2, 3, 4, 5, 6, 7, let's say. And L might be something like this, okay? Now, in this case, what can we do? So again, our idea will be fairly similar. So if you think about this, right? So here, what will be the maximum possible difference we can create? Okay. So if you look at this in this case, here the final answer. So we can just like choose the numbers to be the following thing: You can choose them to be 0, 9, 9, 9, 9, 9, and another one of them will be the first digit. So if I say the first digit is some x here, it will be x times 0, 0, 0, 0, 0. So in this case, the difference will be x plus how many ever 9s you have. You can fit, right? So if you want a closed form answer, it will just be R0. R0 is like this, this x here basically. So R0 times, sorry, R0 plus R dot size minus 1, this times 9. So this will be a closed form answer, but look at my code, I didn't find a closed form answer, I just iterated over it, which is still fine, I think. So it's just outputting answer here. One thing you have to be careful is R is a string, right? So since it's a string, we have to subtract that from the ASCII character 0, so that will ensure that it's the right number. I hope the problem B is clear. So let's move on to problem C. So I'll quickly open the question. Now you can pause this and you can have a look at the solution. So go look at the question and I will show you my solution. Okay, so I thought this was a very interesting problem, right? So okay, so we'll have a look at this. Okay, so let's move on to problem C. So in problem C, it's a very interesting problem. So let's have a look at this, right? So we have two strings S and T. So let's have a look at a couple of things. First thing is Bob either reverses S or either reverses T. But I'm saying it doesn't matter because like it doesn't change how many digits are equal. So reversing T and reversing S are the same thing. So we'll just assume he reverses T always. I think that's a good assumption. Now you have some string S and some string T, right? So let's calculate how many digits differ between S and T. I'll call it C and T. And let's calculate how many digits differ between S and reverse of T. I'll call this C and TT. Okay. Now let's think about this. Okay. Now there are many possibilities. So let's have a look at all of that. So first thing is we can think about C and T. Okay. So C and T means I'm trying to make S equal to T. Okay. Now if I try to make S equal to T, in how many operations can I do it? So that's the big question. So there are a couple of possibilities here. Okay. If C and T was odd. Okay. My claim is I can always do this in 2 times C and T minus 1 operations. I can do this in 2 times C and T operations. I'll tell you why this is true, right? So let's have a look at C and T is odd. C and T is odd means it's the number of places in which S differs from T is an odd number. So the number of places where S differs from T is an odd number, right? And that will be very useful for us because what you can do is you can swap a particular digit. Then what we have to do, string will get reversed. Then we can swap. Then we'll get reversed. But the thing is, C and T was an odd number, right? Since C and T is an odd number, that's very useful because you can end something like this. Okay, so you can do swap, reverse, swap, reverse, swap, reverse. You can keep doing that, but it will end at this position. Now, if swap was if C and T was an even number, you can't do that. Why can't you do that? If you do something like swap, reverse, swap. Okay, swap is an even number. C and T is an even number. Since C and T odd, you can do this. Now both of the strings are still not equal. Why are they not equal? Because the second string is actually reversed. Now since the second string is reversed, they are not equal. But if we do one more rev option, then it's enough because then both of the strings become equal and immediately we're done. So am I being clear here? So if C and T is odd, you can do something like this. And of course you might have more possibilities also. It will eventually end in swap. Here the thing is it will eventually end in rev. Okay. C and T odd and C and T even. Now let's think about C and TT. So C and TT was the case in which you are matching S and the reversed version of T. Okay. So here what can we do? So here also a bunch of possibilities. If C and T was even, what do you do? Well, if C and T was even, in that case what will we do? So in that case the answer will be fairly simple. It will be 2 times C and TT minus 1. Why will it be this? Because you can do something like swap, reverse, swap, you can do reverse. Okay, okay, I mean I'll take this example I guess. So you can do swap, reverse, swap. Okay. Now the thing is, since C and TT is an even number, it will be 2 times CNTT minus 1 because we have done one reverse operation already. So that's why it was swap, reverse, swap, because here we have done one reverse operation. So since we have done like an odd number of reverse operations before this, our string will be reversed. So that will ensure that they are equal. If CNTT is odd, then what we have to do is we might have to do swap, reverse. I'll write this down. Let's say CNTT was 3 for instance. So here's something like this, right? Now we have done 3 swaps, but still the strings are not equal. Why? Because we reversed string t twice. Since we reversed string t twice, it's still not equal. So we have to reverse it one more time. So it will be something like this. So that's why in this case we are doing 2 times CNT operations. So I'll write it over here. 2 times CNTT operations, right? So that's all the possibilities. But one small edge case here. Yeah, if CNTT is 0, that is, then we can definitely do it in 2 operations, because it will be swap nothing and a reverse operation. Like that's an edge case, because if CNTT was even, this formula would say it's 2 times CNTT minus 1, but obviously that won't be correct. So if CNTT is 0, you have to do this. So I hope I'm being clear here. Yeah, so that's it. I'll show you my implementation also. It's pretty much the same thing I told. We just count how many things, in how many indices SI is equal to TI and how many indices SI is equal to the reversed version of TI. And I'm just initializing answer to be some large value. Then I'm taking answer to be the minimum of answer and 2 times count minus 1. Like everything else is the same thing I told you. And in the end, I'm just outputting answer. So I hope I'm being clear in that. So let's move on to question D. So again, you can pause the video and have a look at the question. Okay, right. So I felt that this was a very interesting problem. So let's have a look at this. So here what we have to note is that okay. So I'm looking at problem D, right? So if you look at problem D, there are a couple of things that might happen. So first thing, we are given some value of m. We are given some value of n also, but let's have a look at m, right? So m is really the maximum topic. It's the largest possible topic basically. But the thing is, m is not very useful. In fact, in my code, I don't think I've used m at all. I'll quickly tell you why that is in a while. But yeah, so let's have a look at some test case. So I'll open the first test case. Give me a second. Okay, first test case looks something like this. Okay. I'll go back to my code here. Yeah, okay. So our first test case looks like this. So m is 8, right? So there are 8 possible values. So these are all the m values. Now, so let's have a Boolean array here. That Boolean array will be 1 if a particular child. So I'll move this a bit like this. Here I have all the children, right? So there is child 1. There is child 2, child 3 and child 4, okay. So I'll let this be 1 if a particular student is familiar in the topic, and let it be 0 if the student is not familiar in the topic. So student 1 is familiar with from topics 2 to 6, so it will be like this. Student 2 is familiar between topics 4 and 8, so it will look something like this. Student 3 will be familiar between topics 1 and 7, so it will be something like this. Student 4 will be familiar to 1 and 5, so it will be like this. Now I'm saying the value of m doesn't matter, because let's say the value of m was 1000, right? So I will have 9 here, 10 here, but all that would mean is no student is familiar in these topics. Now, if no student is familiar in a particular topic, that doesn't help us, because that just shifts down the average. That just shifts down because everyone has to lower their hand by 1 unit. So even if m was like 1000, it doesn't help us. So that's why I'm only writing up to the maximum value of n, because that's actually more than enough. So even if m equals 9 here, it's negligible, because that means no student is proficient in it. So really we only care about the maximum R value possible, right? Okay. Now let's proceed. So I'll do one thing here. First thing is I'll sort all of these. So I'll have pairs L comma R, right? The pair data structure. So I'll just maintain a bunch of pairs L comma R. So I'll have a vector of pairs, or a form L comma R. So I hope I'm being clear in that. So let's sort in descending value of L. So if we sort them by the descending value of L, this guy comes first, this guy comes second, this guy comes third, and this guy comes fourth. Right, and since it's sorted in descending order, I guess this guy should come here, but it doesn't matter too much, to be honest. But yeah, so now let's continue. Right, now what are the various possibilities? So the first thing is, what we'll do is that we'll always try to select like some prefix of this. So I'll explain what I mean by that. So I'll always try to select some index till 3. Okay, so so what am I trying to do here? I'm just saying I'll always be selecting like up to index 3. So index 3 will be my upper limit. Actually, why is that? Because the thing is, from 4 everyone knows topic 4, everyone knows topic 5, and that's not very useful for us, because since every single person knows topic 5 and topic 4, it's not useful to have topic 4 and topic 5, because everyone will just raise their hand up by 1 unit, and we don't want that. What we really want is maximize different ones and zeros, right? Now also one small implementation thing here is that if you're lowering your hand goes down by -1, right? So our difference will be like I mean, how many plus ones you have minus how many minus ones you have. But actually you can make the implementation a bit easier by saying, if you lower your hand, let it be 0. So if you lower your hand, your answer is 0, and you just multiply that answer times 2 so as to get the final answer. So I hope I'm being clear in that. So you don't have to lower your hand, you just say your hand remains at the same position, but you multiply whatever final answer you get by 2 so as to make implementation easier. So that's what we are trying to do here, right? So moving on. So m values, this table is there, right? So we sorted them. Now I'm claiming that we'll always take some prefix of this, because that should always be fine. So if you look at my code here, I'll quickly show that. Yeah, okay. Right, so there are just two possibilities, okay? So I'll maintain max L. What is L? Max L, maximum value of L. So in this case, max L would be 4, I guess, right? Okay, so max L will be 4 in this case. So what I will do is I'll iterate over all of these possibilities. So I'll iterate over this, iterate over basically everything else. Now, as I told you, we'll always have some prefix of this. So we can have either these 3, or we can have like let's say these 2, or maybe these 2, or all of this also. So like basically anything is possible. So what we'll try to do is that there are 2 possibilities to be very careful about. Okay. So the first thing is, you might have something like 0, 0, 0, 1, 1, 1, 1, and then you might have some more bunch of zeros here. Now and max L might be somewhere here. So this is max L. All of these are zeros, okay? All zeros. Okay, I'll quickly type it down to avoid any confusion. And you have a few more zeros here also. I'll try to add that also. Okay, so I hope that's fine, right? Now this is first possibility. What is first possibility? Well, in the first case, our answer would just be 5, because oh, by the way, all of these are ones, okay? I hope that's clear. Okay, so our first possibility is that if you ask all of these topics, right? If you ask all the topics in this particular range, our answer will just be 5, right? We just ask all the topics in that particular range. So in that case, our answer will be 5. Now in the second case, actually both of these might intersect. So it might look something like this. I'll try to demonstrate that also. Okay, I'll get rid of this. Give me a second. Okay. I think they should be fine. Yeah, okay. Now all of them intersect, and this stops somewhere over here, okay? In that case, what you can do is that you can just think about this entire prefix all the way up to this point. So in this case, asking these 3 doesn't really matter anymore. Like whether you include these 3 topics or not doesn't really matter, because the first one is also 1 there. So it really does not matter whether you include those topics or not. So instead we'll simplify our lives and just ask all of these topics. So if you ask all of these topics, what will happen? So our answer in that case will be how many ever ones we have over here, because the first guy will be lowered for them, but the second guy will be raised for them. So if you look at this, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. In that case, answer is 15. So these are the two possibilities, okay? So if I take it to my code, that's basically what this code does. So as I told you, I've defined that L max. So if R is smaller than L max, so that's really the first possibility I told you about, then I'll just take the maximum of answer and length. So that's what this thing we're doing here. Otherwise, I'll just do like L max minus L. L max minus L will give you this difference. Okay, I hope I'm being clear in that. Now, likewise, we can do a similar thing for the suffix also. So you might have something like this. You might have some 1 over here. Actually, I can take the same test case also, I guess, if that helps. So here we'll sort out them in the decreasing values of R. So like this has the smallest R, so I'll make this go first. Then this guy. Then sort them by the increasing values of R, right? So this will be the order in which you are sorting them by the increasing values of R. Now in this case, we'll differ min R. So min R will be 5 in this case, right? You can clearly observe that min R will be 5. So I'll call this symmetric case. So min R will be 5 as I told you, and again we'll do the same thing. It's exactly symmetric. We'll iterate over all the possibilities. Again there will be two possibilities. First case you just take it to be length itself. Second case you take it to be how big this interval is. So again we are doing the same thing. So BI, just an implementation, we are sorting them by the values of R, right? Sorting them by increasing values of R. So it makes your life easier if you have them as a pair of A dot second, A dot first. So you maintain it as a pair of R comma L in this case to make implementation a bit easier. So I've defined again R min I told you about, and then I'm just iterating over it, and exact same thing. If L is bigger than R min, then I have to take answer equals max of answer comma len. Otherwise I'll just be taking answer comma R minus R min. So I hope that's clear. Now apart from that, there's one more possibility also. So what will be that possibility? Well, so again let's think about this, right? So in this case, what might happen is you might have it's something like this. So if you notice, both of the above approaches would not give the correct answer here. So if you look at this test case, correct answer would be 5 actually, right? Because you can choose this topic, and then these 3 topics also. But actually, all of our approaches would give the wrong answer here. So to avoid that, we'll have a look at this. So in this case, our answer will be the maximum length minus the minimum length. So it will be some big maximum length interval minus the minimum length interval, and this takes care of all sub intervals basically. So we just take the length of the smallest interval, we just do length of largest interval minus that. So in that case, so here we will be doing 6 minus 1. So 6 minus 1 equals 5. In this case, that will also be covered. So I will show you my implementation also. So here we are just finding the minimum length and the maximum length. So we are initializing answer to be max length minus minimum length, as I told you about. So this is the first case I told you about. I think I explained this already. Second case also I have explained. And we are outputting 2 times answer. 2 times answer because in this case we are actually assuming lowering a hand counts as 0. But actually we want lowering a hand to count as minus 1. So the difference gets doubled. So because of that, in this case our answer will be 2 times answer. So I hope I am being clear in that. So that's it for now. So I hope you enjoyed the video tutorial. Make sure you subscribe to the channel, and if you have any doubts or if you have any corrections, make sure you post it in the comment section. Thank you.